The universe has secrets. This is the voyage to uncover them. There are monsters in the dark, not of fiction, but of physics. Objects so massive, so dense, and so voracious, they defy our understanding of reality itself. We call them black holes. We've found small ones, the ghosts of dead stars, only a few miles across. We've found supermassive ones, the anchors of entire galaxies, millions of times the mass of our sun. We even took a picture of one. We thought we had a handle on the scale of these beasts. We were wrong. Out in the deep, distant past of the universe, something is lurking. An object so large it has no right to exist. A monster that breaks the rules of cosmic evolution. Its discovery presents a profound paradox. There simply hasn't been enough time since the dawn of the universe for anything to get this big. It's an impossible object. And tonight, we're going to find it. Our investigation begins not with the biggest, but with the ones we thought we understood. To understand the impossible, you first have to understand the possible. Imagine our sun, a beautiful, life-giving star. Now, imagine a star 20 times more massive. When a star that big dies, it doesn't go quietly. It collapses under its own immense gravity, squeezing all of its mass down into a point of infinite density. A stellar mass black hole is born. Think of it like crushing a skyscraper down to the size of a grain of sand. All the mass is still there, just in an impossibly small space. The gravity is so intense that at a certain point, not even light can escape. This boundary of no return is the event horizon. These are the piranhas of the cosmos. Dangerous, but small. A dozen or so miles across. We've found plenty of them. They make sense. But then, we looked to the center of our own galaxy, the Milky Way, and we found something else entirely. Sagittarius A. This isn't a piranha. This is a leviathan. 4 million times the mass of our sun, a supermassive black hole. And here, the story starts to get strange. How do you make a leviathan? The simple answer is, you feed it. Over billions of years, gas, dust, and entire stars fall into its grasp, and it grows. Like a snowball rolling downhill, it gets bigger and bigger. This is how we explained the giants at the hearts of galaxies. It's a slow, steady process of consumption. This was our neat, tidy explanation for years. It was a good theory, until we looked further out, which means further back in time. Because light takes time to travel, looking deep into space is like looking into the past. And in the very young universe, astronomers started seeing things that shouldn't be there. Supermassive black holes, billions of times the mass of our sun, in galaxies that were just infants. The snowball didn't have enough time to roll down the hill. It was like finding a 100-story skyscraper built in a single day. The theory was breaking. And that brings us to the king, the monster of all monsters, an object known as Ton 618. Ton 618 is not just a supermassive black hole. It belongs to a new class, ultramassive. When we look at it, we are looking back over 10 billion years into the past. And what we see is staggering. It's not millions of times the mass of our sun. It's 66 billion times the mass of our sun. Let's try to picture that. This isn't like crushing a skyscraper into a grain of sand. This is like crushing a whole city, a whole country, into a marble. The dark sphere of its event horizon is so vast, you could line up 11 of our solar systems, from the Sun to Neptune, end to end, and they would still fit comfortably inside it. It shines with the light of 100 trillion stars, not from the black hole itself, but from the swirling vortex of matter it's actively devouring. A quasar, the brightest object in the universe. TON 618 is the ultimate paradox. A black hole of this size, this early in the universe, simply defies the slow and steady feeding model. It's impossible. So, how is it there? This is where our journey takes us to the edge of science. Two radical ideas have emerged to solve this impossible problem. The first is a story of violence, galactic cannibalism. In the chaotic, crowded early universe, galaxies were constantly crashing into each other, and when they did, their central black holes would enter a gravitational death spiral, merging into one, even larger black hole. It's possible that TON 618 is the result of a long, brutal history of eating other supermassive black holes. It didn't just eat stars and gas. It ate its own kind. But even that might not be fast enough. Which leads to the second, even more profound idea. Direct collapse. What if you didn't have to build the skyscraper brick by brick? What if you could just materialize it? The theory of direct collapse suggests that in the very early universe, under unique conditions, vast clouds of primordial gas could have collapsed directly into a massive black hole, completely bypassing the star phase. They wouldn't start as piranhas, they would be born as sharks, tens of thousands of times the mass of the Sun, right from the beginning. These heavy seeds would then have a massive head start, allowing them to grow to the ultramassive scale of TON 618 in the time available. The James Webb Space Telescope is now finding evidence of these overmassive black holes in the early universe. Objects too big for their galaxies, lending weight to this incredible theory. So, the impossible object at the edge of time may not be a glitch in our observations. It might be a signpost, a relic from a different, more violent era of the cosmos, born in a way we are only just beginning to imagine. It forces us to confront the fact that the universe has more than one way to create a monster. TON 618 isn't just a record holder, it's a key to unlocking the secret history of the universe itself. A history that is far stranger and far more epic than we ever thought possible. Remember, we are all voyagers. Thank you for watching.